All right, good morning, everyone. Thank you so much for joining us. We appreciate you being here on the last day of Summit. We've got 20 minutes here. We've got a lot to go through. If we have any questions, please pull us aside after. We're happy to give demos and answer anything you might have. OK, so we'll be talking about how we leverage DBT and Snowflake to build blockchain data pipelines. I'm Austin. I help manage the analytics team at Flipside. I'm also responsible for our Ethereum and EVM, or Ethereum Virtual Machine data.
I'm Julius from Remigio. I manage the data engineering team here at Flipside and lead the data engineering efforts.
OK, so quick agenda for today. I'm going to give you a little bit of an intro on Flipside, a high-level architecture overview. We'll start digging in a little bit more then on how we really use DBT, talk a little bit about our incremental jobs, how we test, and some of the ways we get creative with views. And then I'll pass it off to Julius for the fun part, talking about Streamline and live query and how we've built really self-service data engineering for blockchain scale data. So a little bit about Flipside. Our mission is really to help blockchains succeed, and we do that with data. So we have 17 blockchains, about 160 terabytes of data available for free in SQL-friendly tables. So we cover most of the public blockchains, Ethereum, Solana, Avalanche, Polygon, and many more, and we're constantly adding new ones as well. And really to do all this, we have over 3,500 DBT models, 1,200 DBT tests, and a lot of macros as well. So we serve some of the largest players in Web 2 and Web 3. We work directly with the Solana Foundation, with Avalanche, and some large financial institutions in Web 2 as well. So we have a unique approach to turning blockchain data into insights. We have a community of analysts. They do a really good job of letting us know what to curate next, what to stay on top of. They help us find any issues in the data of things we've missed. And yeah, we really use Snowflake and DBT and a little bit of AWS to do all of this. So some of the chains we support, kind of our journey and what's coming for us. So we have Ethereum, Polygon, Solana. You can see some of the different logos on there. And then looking forward, some of the chains that are coming soon. So highly anticipated Bitcoin data is on the roadmap and will be released shortly. So high-level overview of our architecture. This is kind of the 10,000-foot view. Again, if you have questions, please see us after. But really, our source data is loaded into S3. We ingest data with a couple of different tools, primarily our Streamline infrastructure, which Julius is going to tell you a little bit about in a bit. We also have a couple internal tools, different ones, and then some external ones as well, for example, Hivo. So the source data, we consider that kind of our bronze layer. We connect AWS S3 to Snowflake with external tables. This is really the raw blockchain data that we're getting off of the node. So a lot of JSON, a lot of hex encoding, all sorts of different encoding structures depending on the chains. But we move it from bronze into our silver layer, and that's really where the real modeling starts to happen. So a lot of flattening, pulling out nested JSON, decoding. In some places, we use external UDFs, other places internal. So we have a Python hex to integer conversion that we do a lot to kind of work around some of the Snowflake big number support issues. And then we have our gold layer. That's really what we present to our customers. So tables in there kind of fall into one of two categories, one being core, so like every transaction and every block on Ethereum. But those aren't necessarily really helpful when you want to dig in specifically to a protocol or NFT trades or something specific on the blockchain. So we also curate on top of that data to make certain protocols and primitives really easy for you guys to dig into. So for example, Uniswap or OpenSea, things like that. The outputs, so the data is available in a few different places. Internally, we do most of our BI with Tableau. We have data scientists building things in Shiny. And then we pump most of our alerts into Slack. So the consumers of our data can really access it in a couple different ways, 3 different ways. First is using our Data Studio, which is a SQL editor, all powered by Snowflake that we've built. We also have an API and SDK that allows more programmatic access to the data for builders. And then lastly, all of our data is available in the Snowflake marketplace. So if you're interested in enterprise shares, we'll have some more info on that at the end. All right, so digging into kind of more technical stuff. We use incremental jobs, of course, and really, these blockchains have so many transactions per day. We want to minimize the amount of data that we need to reprocess. A lot of our jobs are fine-tuned to the point where inserting the rows is, a significant portion of the job runtime. So all of our incrementals just load on recently inserted data. anything new we're going to pull into the tables. We really want to minimize those lookbacks. Just one extra day can double the amount of data that we need to process. OK, so also I mentioned how we use S3 and external tables to access our source data. If you've ever worked with external tables before, you know there can be some performance challenges. But we've developed some highly tuned queries that we then turn into macros and apply everywhere. So on the left there, we use the information schema to access the newly inserted files. And then those are what we're looking to load into that silver layer. So then on the right is just the application of one of those macros. We're running it on a specific table. We input a function for whatever the partition is in there, and that allows us to access the data in the external tables pretty efficiently. So testing, I mentioned we have over 12 or 13,000 DBT tests. They're kind of split into 3 categories. So we do intraday testing, where we're using views to only look at the last day or so of inserted data. We run this multiple times throughout a day to allow us to know if there's any sort of issues popping up. So we're doing gap testing, dupes checks, freshness, things like that. We also do daily testing on a number of our curated models. So here we're looking for formatting issues, things that should have names that don't, things that should have USD prices that maybe don't. And then lastly, we do full testing as well, where we'll test the entire chain history. So 20 terabytes of data for some of the chains, looking for sequence gaps. We don't do this every day just because it is pretty resource intensive. But we use a number of standard macros, but also there are blockchain rules that we can apply as tests. So for example, on Ethereum and EVM blockchains, every transaction should have a receipt. We do 2 separate calls to the node for those, but then we're able to test to make sure everything matches up nicely. So just a simple left join on block number and transaction hash to make sure we're not missing any receipts. And there are a number of other examples just like that, where there's some blockchain rule that we've turned into a DBT macro and are testing our data on. Lastly, getting creative with views. So Snowflake is super powerful. We all love it. But sometimes more compute isn't necessarily the best way to tackle a challenging problem. So I mentioned how we sometimes use external UDFs. One example of that is decoding the event logs from Ethereum data. So when we get data off the node, it doesn't say things in English, right? It's kind of challenging to work with. So we're able to decode those events according to the contract specifications, the smart contract specifications. And to do that, we use a Python package, web3.py, that we've built into an external UDF. We needed to apply it to all of our data, though, and for Ethereum, we had billions, about 10 billion event logs that we needed to decode. We'd use a medium warehouse for most of our stuff, and you can't really select that many rows that quickly on a medium. So what we did was built a number of views that broke up those event logs into different block ranges. So you'll see all the files there on the left. Those numbers at the end correspond to different block ranges. Then on the right, you can see the code for each of those files is exactly the same. We're just triggering the decode logs history macro, which builds the ranges that it needs to run on from the file name. So it's the same code over and over again, just we do it in tiny, tiny pieces. And we were able to tackle this in about a day when on a medium warehouse, when we thought it would take maybe 10 to 12 hours of pure runtime on a 2XL warehouse. So by breaking it up into these tiny pieces, we were able to get it done on a medium. With that, I'm going to pass it off to Julius. He's going to tell you a little bit about Streamline.
Thanks. Good morning, everyone. Do you all hear that? That's the sound of your data silos getting crushed. And today, I'm going to show you how we crush data ingestion at Flipside Crypto. But to do that, let's go over some common sources of data ingestion, some common techniques. Some of you might recall this graph from a Business 101 class, right? We have easy to use versus smart. We're all probably familiar with batch pipelines. They're high volume and high latency, which means we can process a large amount of data, but at a relatively low frequency, probably like a day or every hour, right? So the problem with these batch pipelines is they're not so smart and they're hard to use. They require a data engineer to build the pipeline, usually in another programming language, and they require specialized architecture, right? Another approach are streaming pipelines. These have become more popular in the last decade or so, and they're low volume, low latency. So they're great for real-time use cases, which means they're a little bit smarter, but they require an entirely different set of infrastructure and specialized skill sets to run and maintain and build. Something a little bit better are templated pipelines. These are things like Fivetran or Medallion, right? So they automate batch pipelines and streaming pipelines and make them turnkey solutions. While this approach is smarter and easier to use, it typically doesn't scale well, right? Working in the blockchain space, there's hundreds of new blockchains and tokens that are created every day, and they each have different protocols and APIs for accessing and acquiring those data sets. So waiting for a vendor to kind of build that into their product was just not feasible here at Flipside Crypto. So we had to come up with our own solution. In that process, we wanted to build something better that met our needs, but we didn't want something that was just a little better. We wanted something that was a lot better. So we came up with Streamline. And Streamline is way easier to use and way smarter. It does not require additional skills or programming languages to learn, and it works on your existing infrastructure, which is just DBT and Snowflake. Now, how we got there was just examining all of the current solutions. And all of the current solutions have the same one thing in common. They're all built on these traditional concepts of data pipelines. Now, let's go over what some of these problems are. Right? The first major problem are data pipelines traditionally require data engineers to build them. So that creates cross-team dependencies from the consumer and the people who acquire the data. They're often not reusable. For example, if marketing wants inventory data and accounting wants inventory data, you often have to build two different data pipelines to satisfy the needs of different customers. So this inevitably leads to data teams managing hundreds of pipelines that are fragile and often break. And that leads to poor data agility. If your data engineers are spending their time fixing broken pipelines, they're not spending the time adding value to the company by building new data pipelines to ingest new data sources. If you're also doing real-time, that's 2x the effort. You have to manage streaming pipelines and batch pipelines. And when one of them breaks, you often have to check both of them. So what is Streamline? Streamline is our self-service data engineering platform built for blockchain-scale data ingestion. It's built on top of DBT and Snowflake and AWS. On the right, we have what looks like a DBT model, right? For those of you who are familiar with DBT, you have the config block on the top, and you have your select statement on the bottom. But this actually is our data pipeline. It's just standard SQL. We've written a simple select statement to declare the data that we want to ingest. It's just a simple select statement. We have a where clause, and we say, we want to ingest and get all the block receipts from blocks 1 through 37 million. And the only thing that's different compared to a normal DBT model is the addition of a post hook. So in that post hook, we've defined a custom UDF, external UDF, that declares what the ingestion should be. It says, this model is the source, and we want it delivered in this bronze table as a target. So what about incremental loads? Just like a normal DBT model, you simply change the where query. So we've reused our existing query to define both a historical load and now an incremental load. Only one line of code has changed. So we have this concept of composable data pipelines using SQL that can handle both historical loads and incremental loads. And it's built using SnowSQL and DBT. And it did not require any additional skills or programming languages like Python. So this can be done by anyone who's familiar with DBT or SQL. It's fully self-service. Let's dig deeper into the architecture. So within DBT, we utilize their post hooks to communicate with our backend services. And we also use Snowflake's external tables and external functions as our primary interfaces with our backend. On our backend, we've built a highly scalable serverless architecture to facilitate all of our data orchestration and ingestion. It's built on Lambdas, API Gateway, and S3. So how do external functions work? Well, they work like normal SQL functions, except that Snowflake allows you to call a custom backend service that you've created. So you simply run a select statement and call your function, and the external function will communicate with your backend and process the request. external tables work similarly. They look like normal tables in Snowflake, except they point to an S3 bucket. So you don't have to load your data directly into Snowflake, but they appear there magically. So when we combine these together, we have everything we need to orchestrate a backend service within Snowflake and seamlessly integrate it. Right? So we can call our external function, communicate with our backend, and tell it what it needs to do. And the backend can process and ingest all of the data and in real time deliver it directly to Snowflake via S3 external tables. So let's look at a concrete example. Right? In DBT, we created a DBT model, and we're calling this model to do. And we've defined it as a series of select statements. We have select from all work that we want, or all data we want to be ingested. And we add an except clause and say, we don't want the stuff that we've already done. Right? And DBT, when you run that model, will create this view. And so what happens after the model is run is the post hook is invoked. So that calls our external function ingest. And ingest communicates with our backend and says, all right, what is my work queue? What VW to do is my work queue, and where should I deliver the data? And deliver it to bronze.todo, which is our external table. So once that function is executed, Streamline will go ahead and read that view, grabbing all 37 million rows as the data that it needs to process. And it'll go out to the blockchain and seamlessly scale out and make 37 million requests all at once. And the data then gets delivered directly into S3 in real time. And the next time the job runs, the same view is hit, and because of the accept clause, we'll only process the data that we've missed or have not loaded yet. So let's look at a deeper dive into that model. We have that same historical model as before, with the same post hook and the same config block. Right? We have the ability to pass additional directives and parameters into this ingest function. We can define scale and batching, so that if we say, oh, this load is taking too long, marketing comes to us and says, we need to sign this customer tomorrow, but we need to get the data today. So we just change one of our parameters, like workers, and say, instead of 10 workers, we want 1,000 workers. And our backend will seamlessly horizontally scale to that many workers. As I mentioned before, failure, all our models are self-healing because of this accept clause. So if there's a problem that happens, or there's a problem with data ingestion, or we have missing data, the next time the model runs, the view only picks up the things that have not been processed yet. So this is powerful. This enables our data engineers to never have to deal with missing data issues. Here's an example of the same query, the same model, but as an incremental model, or incremental load. Notice the only thing that's changed is the where clause. So instead of defining a block range, now we're defining that we want any block number that is greater than the last one we loaded. So now we can define a streaming pipeline that runs at every minute, ingesting data every minute, but only the newest data. So those of you who are experts at DBT might be thinking to yourself, well, these are two different models. Why not combine them? And you can do that, and that's actually what we do in practice. We've combined these models using the isIncrementalDBT function. And so now you have a singular model that can handle both historical loads and real-time incremental loads. But there's more. The interface that we use with external functions provides a direct way to stream data, not just in real time, but instantly to our end users. And we call this live query. So in a typical streaming architecture, you'll be running a load like every minute or so, getting data incrementally. And that data needs to land on the table before it's available for a user to query. But with live query, we've bypassed all of that infrastructure and paradigm. There is no additional infrastructure to stream. So when this request is made, a point-to-point connection is made to our external data source, wherever it is on the internet. That data is returned to the external function and delivered directly to the data set, so it never lands in the table. So now we have the ability to build queries and live views that return data in seconds instead of minutes. So what is Streamline? Well, it's built on DBT, Snowflake, and AWS, and supports composable data pipelines. right? And just to recap on what composability means, on the right, I have some examples of the same query, the same live query that I showed you earlier, ingesting data from an external API somewhere on the internet, could be anywhere. And this data is a live query delivered directly to the customer. We can use the same query, add a create view statement to it, and now it instantly becomes a live view. So anyone querying this view will instantly get live data. Simply change that one line of code, add a create table statement to it, and we suddenly have a historical table. So we're reusing the same query over and over again to build different data pipelines and different types of objects. We can also use a union all to combine both live and historical data into the same view or table. So that's the power of the composability of DBT, SQL, and Streamline. And the best of all, it's self-service. Notice there was no example here of any Python code. Doesn't require any knowledge of any specialized skills or programming or architecture. It's all SQL. And I'm happy to announce that this live query feature is something we released yesterday at Snowflake, and it's live right now on our website. So feel free to scan our QR code to get a live demo. It's completely free, and anyone's able to use and access our data on that platform. Thank you.